Trigonometry is a very important and easy chapter when it comes to NDA. But it becomes little complicated when students do not know the basic concepts and the formulas. What is advised to you? Please read the upcoming lectures and then you will be able to solve the trigonometry questions very easily. First, when we discuss about the word trigonometry, so Trygon metron. Trigonometry word is formed from three Greek words. Tri means three, gon means sides, and metron means measure. Actually, trigonometry is like quite useful in every discussion of shapes, in every shape, but it is especially relevant to triangles. Okay. In the ancient time, trigonometry defines relations between elements of a triangle. In a triangle, there are six basic elements. What are they? Three sides and three angles. Any three line segments will form a triangle if and only if those three sides are following the triangle inequality. What is the triangle inequality we were discussing in our previous class, right? That the sum of the two shortest side should be greater than the third side. In Euclidean geometry, the sum of three angles should be 180 degree, then only those three sides can make a triangle. These requirements impose limitations on the manner in which the relations between the elements are defined. For a triangle, there are six elements, three sides and three angles. The sum of all angles in a triangle has to be 180 degrees, and the sum of any two sides should be greater than the third side. So these are the limitations in which the relations between these six elements are defined. Now we are very sure about side. What is a side? Basically, it's a line segment and its length is defined. Let's now talk about angle, which is of more interest to us in this chapter. Angle is just a measure of rotation. Measure of rotation between what? If we rotate a ray, what is a ray? That has a one end point and is extending to infinity. That has no end point. If the ray rotates about its initial point, let's say if this is the ray, oh, where it's gone. Let's say if this is the ray and it gets rotated from its initial point in this manner, like this, from its initial point. The initial point remains the same, but the ray has rotated some manner. So this was the initial point. Let's call this common point as O. The initial position of ray is OA and the final position as OP. Now, If the movement of the ray from its initial position is clockwise, then the angle clockwise is like this. Then the angle that we are measuring will be negative, will be having a negative symbol. If the movement of the ray, the final movement, is in counterclockwise direction, anti-clockwise direction, that we are referring to here, then the angle will be positive. Is that clear what an angle is?
Yes, sir.
Okay. Let me draw a similar diagram for negative angle 2. Rotating counterclockwise this time. So the angle will be negative. So this is the example of angle becoming positive when angle is counted anti-clockwise. And this is the example of angle becoming negative when angle was measured in a clockwise manner. I hope that's now clear. Is that so? Is it clear? What is an angle? Just the measurement of the rotation of a ray from initial position. When the common point is fixed, the point of rotation, this is fixed. Let us name it. This is vertex about which the rotation is happening. Vertex. Let's now discuss some systems. Systems for manage measurement of angles. The first very basic system that we all know about is the British system, or we call it sexagesimal system, also known as the British system. So whenever we discuss about ray, we are discussing about this. See, so this particular ray can have its movement. Oh my God, how should I? Draw a line. Now, anyways, let's consider it like this. Okay, so this can move. This is the initial part. So This can move like this, making a circle, right? It's making a circle here. So if this ray starts moving around and completes a full circle, uh, now, so this whole angle that it has made going from here to here again, making a full circle, is uh, is given as referred to as 360 degrees, that it has covered 360 degrees while completing a circle in British system. Is that a full circle in a sexagesimal, that is a British system, is given by 360 degrees. And when we talk about the French system, that is known as the centimal system. It is the French system. In this, a full circle is given by 400 degrees. So here, the 1 minute, 1 by 100. Now, this is not called as 400 degree. This is referred to as 400 grades. Now, 100 grade, 1 by 100 grade is called as a minute. As we were talking earlier, that 12 hours have 12 into 60 minutes. 12 into 60 minutes. So we can call it 12 into 60 minutes, and here 360 itself. Then how we can further write it? That 1 by 60 degree is equivalent to 1 minute. Okay. Here, and 1 minute is different, is denoted by 1 apostrophe. Anyways, that's not important. Centesimal system is not important. What's important here is just to know that what are the grades, not the minute system. We use sexagesimal system in India, that is given by the British. Okay. There is one more system, that is circular system. In this, we calculate radian. So radian measurement is done here. So here basically the initial part of the ray is this, and then a circle is assumed. Let us draw a circle directly. A circle is assumed, and let's say that the final part of the ray is this final position. So here, this angle is measured in radians, and this will be calculated by, let's say this is the radius of the circle. So, and this white part that I'm shading, I'm coloring, this length of the arc. This length of the arc L. By dividing L by R, this comes out as the radian. And a radian is, let's say, what will be a full circle here? The full circle, the theta for full circle here will be theta will be, what will the arc? upon radius. Na? What is the arc for a full circle? That is the circumference. And radius remains radius. Circumference for a circle is 2 pi r divided by r. So that is the value of radians given by writing c instead of the degree sign. And this is known as the radians for a full circle. That is 2 pi radian. Now to revise it all, 1 degree in the British system that we are going to use is equals to 60 minutes. These are minutes. These are degrees. And 1 minute is equals to 60 seconds. This is minute. And these are seconds. Okay, what else? In degree system, a full circle was 360 degrees. In French system, centesimal system, a full circle is 400 grades. In radian system, a full circle is 2 pi radian. Okay, if that is so, let's establish some relationships between radian, degree, and grade. Let's do that. Here we can see in all of the 3 equations, 3 results that we have drawn. Observation number 1, observation number 2, observation number 3. The left hand side is equal. So the right hand side should also be the equal. 360 degrees must be equal to 400 grades must be equal to 2 pi radians. Now we see that 2 is common everywhere. Okay, so let's divide by 2. 180 degrees, 200 grades. That becomes pi radian. Okay. For further convenience, you can also divide it once again. 90 degrees, 100 grades, and pi by 2 radians. This is important. This relationship between the grade, between the degree, the grade, and radian is important. Only like you can remember this much, this only, you will be able to find out the other with the use of this. Is that clear? Is that clear or no? And I was doing a mistake here by relating the minutes in the clock system. Actually, it's not just clock, but it is just this only. Like this is the end result, and this is how we learn. We cannot relate it with clock, and we'll be very confused whether we are talking about RN, second, or minute. So it's just about the sexa decimal system. There is a British system. Okay. So here we should not relate with clock. Are there any questions?
No, sir.
It is as simple as that. That 1 degree is equals to 60 minutes. 1 minute is equals to 60 seconds. Simple. Now, as that we are discussing about the relationship, what is more important and will be very useful for you is the relationship between degree and radians. The interconversion is important. So here we have talked about that 180 degrees was equals to pi radian. Yes, 180 degrees is equals to pi radian. So means 1 degree is equals to pi by 180 radians. Nice, nice. We have to convert x degrees. So let's multiply by x on both of the sides of the equation. So if we have to multiply x on the both sides, then x degrees into x pi 1 by 180, that becomes the radian. So let's take an example. We have to convert 90 degrees into how many radians will be there in 90 degrees. So we have 90 degrees, the formula is x. So whatever the degree is, 90 into pi divided by 180. And this is our answer. 92s are this. So this is pi by 2 radians. The answer. 90 degrees pi by 2 radians. Okay, as simple as that. So basically whatever number do you have, whatever number of degrees do you have, just multiply it with pi and divide it by 180, and you will be getting the radians. That's the formula for converting any degree in radian. Is that clear?
Yes, sir.
Let's now discuss about the conversion of radian to degree. So we know pi radian is equals to 180 degree. Okay, let's divide both sides by pi. 1 radian is equals to 180 by pi degrees. So simply if you have any radian given, just multiply it with 180 and divide it by pi, and that will be the radian. Let's take an example. If you have, let's say, pi by 4 radians. So simply do one thing, multiply the pi by 4 with 180 and divide it by pi. And this will be the answer in degrees. This will be the answer in degrees. Degrees. Pi cancels pi, 180 by 4 is 45 degrees. Is that clear?
Yes, sir.
Great. So let's now discuss some more complex examples. Find the radian measure of minus 37 degree 30 minutes. Now we are well aware that 1 degree is equivalent to having 6 minutes. Here we have how many minutes? 30 minutes. Let's divide both sides by 2. 1 by 2 degrees is equals to 60 by 2, that is 30 minutes. So that means how many degrees do we have? Minus 37 degrees and plus half degree. If that is so, we can write it as like minus 37 and half degree. Let's keep the minus outside. 37 into 2, 74 plus 1, 75 by 2 degrees. Degrees. Is that clear that how we have compounded the degree from minutes and degree? Yes, is that clear?
Yes,
Yes or
sir.
no? Yes. So now making when we have to convert any given degree into radian, so what we do? First of all, we'll multiply it with pi and divide it by 180 to make it into radians. Now this has converted into radian. Let's solve it further. 75. Now, is it divisible by 25? No, then this will not be divisible by 25. Let's divide it by 5. 75 by 5 is 1, 5. 180 by 5 is 3, 6. Okay. So the answer comes out to be minus 15 pi divided by 72. This is the answer in radian. Is there anything? Yes, 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 yes. We can divide it by 3. 15 by 3 is 5. 72 by 3 is 2, 4. So minus 5 by 24. Radians is the answer. Is the solution clear?
Yes, sir.
Here, do not get confused that whether we have to subtract 37 and half. No, just keep the negative side out and make a mixed fraction, like solve the mixed fraction first. Let's solve another question. This is more interesting. The minute hand of a clock is 10 centimeter long. How far does the tip of the hand move in 20 minutes? We have to tell the answer in radians. In basically centimeter, sorry, because we have to calculate the distance, how far. Okay. So the minute hand of a clock is 10 centimeter long. Okay. So if you are talking about minute hand, so the 360 degrees are equivalent to a minute hand completes around in 60 minutes. Yes.
Yes, sir.
And we have to calculate that how far does it move in 20 minutes. So let's divide it. 36 degree by 60 is equals to 1 minute movement. So let's become 6 degrees is equals to 1 minute. Now, if we talk about 20 minutes, then 6 into 20, 6 into, sorry, I should write in manner. So let's multiply 20 on both sides. 20 into 6 degrees is equals to 20 minutes. So in 20 minutes, 120 degrees will be the hand movement. So this is given in degrees. But we know about a formula. We need to basically find that 120 degrees will be approximately like this. If the hand is moving like this, sorry, like this, for to be positive, angle to be positive. Anyways, so we have to calculate the distance. We know this is arc. And we know that theta is equals to arc upon radius, where theta is in radians. Okay. So we have got the angle 120 degrees. Let's convert 120 degrees into radians. by multiplying by pi and dividing it by 180 degrees. That makes it a radian. Degree cancel, and 12, 6 2 are 12, 6 3 are 18. So that becomes 2 pi by 3 radians. Now 2 pi by 3 is equivalent to r. That is what we need to find out. The radius is 10 centimeter. Why? The minute hand is equals to the radius. Okay. So the r equals to 20 pi by 3 centimeters, which is precisely the answer. Is everything clear? Any doubt?
No, sir. No doubt.
Okay. So let's now discuss about angles more. There's one more important thing. In 1 radian, there are 57 degrees, 16 minutes, and 22 seconds. And in 1 degree, there are 0.017 radians. This difference is very much important for you to understand that which is bigger. 1 radian is bigger or 1 degree is bigger? Yes, can anyone tell me? 1 radian is bigger or 1 degree is bigger? It's
One
simple.
degree. Yeah.
1 degree is not bigger, 1 radian is bigger because in 1 radian there are 57 degrees and some more, right? So degree is smaller unit and radian is a bigger unit. Okay? And there exists a PYQ asking sine of 1 radian is bigger or sine of 1 degree is bigger. So basically we have to tell the inequality between them. So sine of 1 radian is basically sine of 57 degrees comparing to sine of 1 degree. And we know the sine's graph, it starts from 0 and it keeps on increasing till 90 sine theta. So from 1 degree to 57 degree, it's going to just rise. Sine of 1 radian is greater than sine of 1 degree. Is that clear, everyone?
Yes, sir.
But it's completely opposite with cos, because cos value starts from 1, it keeps on decreasing till 90. So cos 1 degree will be greater than cos 1 radian, then cos 57 degrees. Is that clear?
Yes, sir.
Okay, let's now talk about some trigonometry. Okay, so let's now start with discussing the right angle triangle. Let's name this as O. This as A. This is B. If we are discussing this angle, I should have taken this whole diagram. It's mirror image. Should we write it like this. Nice. B will look like B. So if we are going anti-clockwise, then there will be some positive angle. And we know in a right angle triangle, the side that is just opposite with the angle is known as the perpendicular. So here AB is the perpendicular. Or should I represent with P only? And the adjacent side with the angle is known as the base. Should I refer it with this B only? And we know the side opposite to the right angle triangle is the hypotenuse. Let me write H for it. Capital H, capital B, capital B. Capital B. Okay. Now, it was considered that, and what we are doing here, actually, we are just tracing the ray OA. The initial position of the ray was OA, and then it has moved to this position. It's a final position. And the O is basically vertex. Okay. And after the movement, we have taken some point on the ray and some point here. Basically, the perpendicular on the x-axis. This is, let me draw a line. This is the x-axis. We have taken a perpendicular on this point, some point, forming a right angle triangle. If we discuss about the relations here, when we will divide the hypotenuse, or should I say the perpendicular with the hypotenuse, I will get, and I'll call it as some ratio. I'll call that ratio as sine of theta. If I take the base and then divide it by the hypotenuse, the ratio, I'll call it as cosine of theta. I'm writing cos theta. This is the short form of cosine. If I divide the perpendicular by base, then I'll call it as a tangent of theta. I'm writing tan. It is actually tangent. Okay. So let me revise again. That sine theta is P by H. Cos theta is base by hypotenuse. Tangent of theta, that is tan theta, is perpendicular by base. There are others also. Cosec theta, just the reverse, multiple inverse of sine theta. Sec theta, just the multiple inverse of cos theta. Cot theta, just the multiple inverse of tan theta. Instead of learning all these 6 formulas differently, I have a trick for you to make them all easy for you to learn. Write sine, cos, tan theta, and write their multiple inverses just in the respective denominator place. Here write cosec theta. Here write sec theta. Here write cot theta. Now what is sin theta? Sin theta is perpendicular upon hypotenuse. What is cos theta? Base upon hypotenuse. What is tan theta? Perpendicular upon base. Now if you compare, that sin theta is P by H, cos theta is B by H, tan theta is P by B. So this makes it very convenient for you to learn, and just learn it by Pandit Badri Prasad. Acronym. Har har bole. These are some acronyms for you to learn them. PB, HHB, and on the other side, sin theta, cos theta, tan theta, their multiple inverses on the respective denominator places. Cosec theta, sec theta, and cot theta. Is that clear?
Yes, sir.
Now, after like discovering all these 6 trigonometric ratios, we are calling them ratios because they are basically the ratio of perpendicular in the hypotenuse. So after observing these trigonometric ratios, we were playing with these. So we were taking the square of sine theta and also the square of cos theta. We were discussing about it. What is sine theta? Sine theta is perpendicular upon hypotenuse whole square. Plus what is cos theta? That is based upon hypotenuse b by h whole square. If we solve it, take h square as the LCM, p square plus b square is equals to sine square theta plus cos square theta. We know one thing for sure, that in right angle triangle, according to Pythagoras, perpendicular square plus base square is equals to hypotenuse square. And here, perpendicular plus base square also becomes hypotenuse square. And on the left hand side, this is the same. Further it become 1, which is your identity taught in the class 10th. This is how it is derived. Clear? Yes or no?
Yes, sir.
Yes. Similarly, others were also calculated. How exactly? Let's find out. So sine square theta plus cos square theta is equals to 1 as per our the discussion. So let's divide the equation by sine square theta. Then let's see what happens. Sine square theta. Okay, we are dividing it by sine square theta. Sine square theta by sine square theta becomes 1. Cos square theta by upon cos sine theta becomes, let's write it like this. Cos square theta upon sine square theta is equals to 1 by sine square theta. Let me write it like this. We are aware that tan theta is p by p, which can be further written as p by h into b by h. P by h is basically sine theta and b by h is basically cos theta. This can be written as multiple inverse cos theta upon sine theta. So hence here cos theta by sine theta is cot theta, and its square cot square theta. Now notice one thing, that I'm writing the square on cot, not theta. 1 by sine theta is what? Cosec theta. Its multiple inverse. This is cosec square theta. If we rearrange it, it becomes 1 is equals to cosec square theta minus cot square theta. Is that clear? Second identity. Clear or not? This is the second identity. We had the result sine square theta plus cos square theta equals to 1. Let's divide it by on both sides by cos square theta this time. Sine, now this becomes sine theta by cos theta whole square plus 1 is equals to 1 by cos theta whole square. We know sine theta by cos theta is tan theta. Its square tan square theta plus 1 is equals to 1 by cos theta is what? Sec theta. Let's see. See, 1 by cos theta is sec theta. Let me also write here that sec theta is 1 by cos theta and cosec theta is 1 by sin theta and tan theta is equals to 1 by cot theta. Nice. So here this is sec theta whose square sec square theta. Rearranging it becomes sec 1 minus sec square theta is minus tan square theta, which is our identity. Clear? Any doubts? No doubts.
No doubt, sir.
So I have a question. What is this? A square minus b square, algebraic identity. What will be its expansion? You have known it, but please reply on time and have courage to fail. Okay, a square minus b square is equal to a plus b into a minus b. Similarly, for these identities also, we can say the same thing. Into sec theta minus tan theta. Okay, if that is so, and it was given as equal to 1, right? So 1 is equals to sec theta plus tan theta into sec theta minus of tan theta. This was given as equal to 1. So I have just written sec square theta minus tan square theta, which is equals to 1. So sec theta plus tan theta is the multiple inverse of sec theta minus of tan theta. And so, similarly, we can say for cosec theta. Or cosec theta minus cot theta is also the multiple inverse of the other. Is that clear? So these two are important observations. These two are important observations. Clear? Yes?
Yes, sir.
Yes, sir.
Okay, then the lecture for today is over. Thank you.